Imagine a world where the skies are not filled with water, but with shards of molten glass hurling sideways at unimaginable speeds. Welcome to HD 189733b, a planet so extreme it defies everything we know about habitability. This is not science fiction. This is a real planet, and it's one of the most horrifying places in the universe. Discovered in 2005, HD 189733b is a gas giant located 63 light-years away in the constellation Vulpecula. At first glance, its deep blue hue might remind you of Earth's oceans. But don't be fooled. This planet is anything but serene. Its vibrant color comes from silicate particles in its atmosphere, scattering blue light. And those particles? They're the key to its terrifying nature. HD 189733b is a world of extremes. Its atmosphere is filled with silicate particles, which condense into molten glass under the planet's scorching temperatures. But here's where it gets worse. Winds on this planet reach speeds of up to 5,400 miles per hour, 7 times the speed of sound. These winds whip the molten glass into a horizontal rain, slicing through the atmosphere at supersonic speeds. Imagine standing on this planet. If you could survive the heat, you'd be shredded by a storm of glass. And speaking of heat, HD 189733b is not a place you'd want to visit. With temperatures soaring to 1,700 degrees Fahrenheit, it's hot enough to melt lead and glass. The planet orbits its star at a distance 30 times closer than Earth is to the Sun, completing an orbit in just 2.2 days. This proximity locks it in a perpetual inferno, where even the night side is scorching hot. But the glass rain and extreme heat are just the beginning. HD 189733b is tidally locked, meaning one side always faces its star, while the other is in eternal darkness. This creates violent temperature differences, fueling storms that rage across the planet. Add to that the constant bombardment of radiation from its star, and you have a world that's as deadly as it is beautiful. So why study such a hostile world? HD 189733b is a prime example of what scientists call a hot Jupiter, a gas giant that orbits close to its star. By studying planets like this, we learn more about the diversity of planetary systems in the universe. It also helps us understand the limits of habitability and the extreme conditions that can exist beyond our solar system. HD 189733b is a reminder of how diverse and extreme the universe can be. While Earth is a haven of life, there are worlds out there that are unimaginably hostile. From glass rain to scorching heat, these planets challenge our understanding of what's possible. And as we continue to explore the cosmos, who knows what other terrifying or fascinating worlds we might discover. Imagine a world so hot, it burns brighter than most stars. A planet where the surface temperature reaches a staggering 7,800 degrees Fahrenheit, hotter than some stars themselves. This is Kelt 9b, a planet on fire and one of the most extreme worlds ever discovered. Welcome to a place where the universe pushes the limits of what a planet can endure. Discovered in 2017, KELT 9b is a gas giant located 670 light-years away in the constellation Cygnus. It orbits a massive blue star called KELT 9, which is nearly twice as hot as our Sun. But what makes this planet truly extraordinary is its searing temperature. Kelt 9b is the hottest planet ever discovered, with dayside temperatures reaching 7,800 degrees Fahrenheit, hotter than the surface of some stars. Kelt 9b is so close to its star that it completes an orbit in just 1.5 Earth days. This proximity locks the planet in a deadly embrace, with one side perpetually facing the star and the other in eternal darkness. The day side is so hot that molecules in its atmosphere are torn apart, and metals like iron and titanium exist as gases. The planet is literally evaporating, leaving a trail of vaporized material in its wake. The star KELT 9 is a monster. It's a blue supergiant, nearly 3 times the size of our Sun and twice as hot. Its intense radiation bombards KELT 9b, stripping away its atmosphere at an alarming rate. Scientists estimate that the planet is losing millions of tons of material every second. In cosmic terms, KELT 9ba is living on borrowed time. The temperature difference between the day side and night side of Kelt 9b is staggering. While the day side is a blazing inferno, the night side is relatively cooler, though still scorching hot at around 4,000 degrees Fahrenheit. This extreme contrast creates violent winds that race across the planet at supersonic speeds, carrying heat from the day side to the night side. So why study a planet that's literally burning up? Kelt 9b is a unique laboratory for understanding the limits of planetary survival. It challenges our assumptions about how planets form and evolve, especially in such extreme environments. By studying KELT 9b, we gain insights into the fate of planets orbiting massive stars and the processes that shape their atmospheres. Kelt 9b is a reminder of the incredible diversity of planets in the universe. While Earth is a haven of life, there are worlds out there that exist in the most extreme conditions imaginable. From scorching heat to evaporating atmospheres, these planets push the boundaries of what we thought was possible. And as we continue to explore the cosmos, who knows what other fiery or frozen worlds we might discover? Imagine a world so dark, it absorbs almost all the light that touches it. A planet blacker than coal, lurking in the depths of space. This is Trieste 2b, the darkest planet ever discovered. A place where light goes to die. Welcome to a world that defies our understanding of what a planet should look like. Discovered in 2006, Trieste 2b is a gas giant located 750 light-years away in the constellation Draco. It orbits its star at a distance of just 3 million miles, so close that it completes an orbit in only 2.5 Earth days. But what makes this planet truly unique is its darkness. Trieste 2b reflects less than 1% of the light that hits it, making it the darkest planet ever found. Scientists believe Trieste 2b's extreme darkness is due to its atmosphere, which contains light-absorbing chemicals like vaporized sodium, potassium, and titanium oxide. These compounds absorb nearly all the light that reaches the planet, giving it an otherworldly pitch-black appearance. Even the faint glow from its scorching hot surface, heated to 1,800 degrees Fahrenheit, is almost entirely swallowed by the darkness. Trieste 2b is tidally locked, meaning one side always faces its star, while the other is in perpetual darkness. The day side is scorching hot, but even here, the planet's atmosphere absorbs almost all the light, making it appear as a faint, ghostly orb. The night side, on the other hand, is a void of absolute darkness, colder and more mysterious than anything we've ever seen. So why study a planet that's almost invisible? Rias 2b challenges our understanding of planetary atmospheres and their composition. By studying its light-absorbing properties, scientists can learn more about the chemical processes that occur in extreme environments. It also raises fascinating questions about how such a dark planet could form and evolve. Rias 2b is a reminder of how diverse and mysterious the universe can be. While Earth is a vibrant, life-filled world, there are planets out there that exist in the shadows, defying our expectations. From scorching hot gas giants to icy, barren worlds, the cosmos is full of surprises. And as we continue to explore, who knows what other dark or dazzling worlds we might discover.